Today we're going to look at the discriminant. So we've used the quadratic formula to find the roots of a quadratic equation in standard form, ax squared plus bx plus c equals 0. What we're going to focus on is specifically part of that formula, the part that is underneath the square root sign, b squared minus 4ac. When we talk about something underneath a radical sign, we call that the radicand. So we're going to look at the radicand from the quadratic formula. The idea behind the discriminant is that it can be used to discriminate between the different types of roots from a quadratic equation, and you can do this without having to solve the equation. Now, we have three possible kinds of solutions, or three different nature of the roots. The first possibility is that the roots are distinct and real. That means we have two unique roots, or two solutions. The second possibility is the roots will be equal and real, which essentially just means we only have one unique root. The third case is that our roots are not real because they result from an imaginary number. We say 0 real roots or no solutions. Let's look at when each of these cases would come up. Our first case is when the discriminant is positive. So we calculate b squared minus 4ac, specifically this part that is underneath the square root. If we calculate just that part, I'll call it d for discriminant, and d is greater than 0, we know we're going to have a positive number underneath the square root sign. When we take the square root of that number, in one case we add it, in the other case we subtract it. We will end up with two different numbers in the full calculation. So this doesn't give us the solution, but it does tell us that there will be two distinct real roots or solutions. The second possibility is when you calculate the discriminant and you get a value of 0. The idea behind this is that if you calculate that radicand underneath the square root sign and it's 0, you'll be taking the square root of 0. When you add the square root of 0 or you subtract the square root of 0, it's still a 0 either way. It's not changing your value. So when we do our calculations, we will only get two equal roots or one unique root. Our third case is when you calculate the discriminant and the discriminant is negative. So I'll say that d, the discriminant, is less than 0. In this case, underneath the square root sign, we're going to have a negative number. We can't actually take a square root of a negative number. That is no longer a real number, it's now an imaginary number. So in this case, if you run into that case where you would be taking a square root of a negative number, we say we have imaginary roots or no real roots. Let's look at a little summary of the three cases. So this is going to compare our quadratic equation along with the equivalent quadratic function. If we were to graph this, then instead of having y equals, we set y equal to 0 and we find the x values or x-intercepts. Our first case, when we have a positive discriminant, is that we have two distinct real roots, or equivalent, we have two x-intercepts. Our second case, when our discriminant is equal to 0, we only have one unique root or two equal real roots. I'm also going to write one unique root here. You want to be able to recognize either term and know what it implies for the discriminant. Our third case, a negative discriminant, can either be described as two imaginary roots or no real roots. And the equivalent graph would have no x-intercepts. Now, if we want to find the nature of the roots, all we do is we calculate the discriminant. So our formula for the discriminant, I'll call it d, is just b squared minus 4ac. Notice there's no square root sign, it's just what goes underneath the square root sign. Now, for this equation here, we have a is equal to 25, b is equal to negative 20, and c is equal to 6. If we calculate our discriminant, we'll do negative 20 squared minus 4 times 25 times 6. That's going to be 400 minus 600. So our discriminant is equal to negative 200. If we think about having a number underneath the square root sign and that number being negative, is that possible? It's not possible. Our discriminant is negative 200 without the square root, but it tells us that we would be taking a square root of a negative number. So we say that there are no real roots, or we could say that there are two imaginary roots. And it's much faster than actually solving the equation to decide how many roots are there. Let's look at another example. For this one, we have an equation missing a little bit. We have x squared minus 6x plus c equals 0. And we want to find what values of c would give this equation two imaginary roots. Again, let's use the discriminant, but let's identify what we know so far. We know that a is equal to 1. We know that b is equal to negative 6. We don't know c. That's what we're trying to find. For there to be two imaginary roots, b squared minus 4ac, our discriminant, must be less than 0. If it's negative, we know there are no real roots. There are two imaginary roots. So let's say that negative 6 squared minus 4 times 1 times c is less than 0. And we're now going to try and solve the inequality for c. We can do this kind of similarly to solving an equation, just with an extra step. So simplifying slightly, we say that 36 minus 4c is less than 0. I'm going to subtract 36 from both sides of the inequality, so minus 4c is less than negative 36. In my next step, I would like to divide by negative 4, but this is where the extra step comes into play. When you're solving an inequality, if you multiply or divide by a negative number, it's going to change the direction of the inequality. So when we divide, we get c and positive 9, but we now get c is greater than 9. So when we're asked what values of c will give us two imaginary roots, anything where c is greater than 9 will make our original discriminant less than 0. So our solution is c is greater than 9. All of those values of c result in two imaginary roots. This is where I like to usually write a little reminder when dealing with inequalities. So the reminder is that for questions like this, if you are multiplying or dividing an inequality by a negative number, that will change the direction of the inequality. And that's all we need to know for the discriminant.